Yeah, the panel will be moderated by Arup from Idaho National Lab. I'll hand over the mic to him. Go ahead, Arup. Thanks.
Yeah, okay. Let's get started. Right on time. Okay. Hey, Arup Bhuyan from Idaho National Laboratory. Really my pleasure to host this panel of really exceptional panelists. I'll introduce them at the beginning. Martin, can you hear us now?
Yes, I can. Can you hear me?
I think, can you hear it back? Dr. Weiss? Yeah, okay, cool. Thank you, folks, all of you folks back there who made it all this looking pretty good. So thank you. So we got a really good panel. I'm very excited on 6G security and privacy, right? And as you know, 6G standards themselves written by 3GPP are about 2 years yet, towards the end of probably 2028. And then we have the actual, normally we have to do the commercial trial, right, at the beginning. So that probably will be another 2 years. So 2030 probably, before you see anything in the field. So this is an awesome time to talk about what should be baked in, right, for security and privacy. At least we can talk about what are the concerns, what do we see. So we'll do first take a look at brief discussion on what is new in 6G, right? What are they talking about would be included in the 3GPP standards. And then as you know, anything new you bring in, there's always new attacks, surface attacks created, new security and privacy concerns. So we'll discuss that a little bit. But first, what I'll do, I'll take a few minutes to introduce the speakers, and then we can, after that, please give a warm welcome with a huge round of applause, which I'll start. And then we'll let each panelist spend a few minutes talking about what their focus is. Then I'll start the discussions just to anchor ourselves in with a couple of very important topics in 6G. Some of them our speaker from Qualcomm did mention in a very good talk right before the break. And then we'll open it up so that you get to ask some questions. But first up, let me start with, I feel very fortunate to have this panelist. We have a mix from, as you'll see, from the government, from the university, and from the industry. So the first, let me introduce Dr. Martin Weiss, and he's the director of the FutureG Applied Research. Now that FutureG of US government, which is part of now what is called DoD, DOW, OUSD, OUSW, right? So that is the FutureG team in government. DoD is a team that's now focusing on 6G. They will be looking and looking from the whole government, right? And so with that capacity, then Dr. Weiss promotes the solutions or the research that will lead to 6G applications that will be commercially available that will be also useful for the government. So he is certainly trying to promote research to have that dual use case situation, which is the best situation, right? Because government cannot drive use cases themselves. So, and he is actually comes from a university. He was professor of at the University of Pittsburgh. So next we have Dr. Ted Woodward. He's a technical director for the same FutureG team in government, and he is also a research professor from University of Maryland. So he is, he has been very focused on connecting the new research to invent, innovations. Again, not just for commercial but also government, right? So, and they will hear more about that from him and others. So, and then we move to universities. We have Professor Nuria Gonza lez-Prelcic. Am I pronouncing it right? Yeah. Okay, right from this backyard here, University of California, San Diego, and her one of the main research interests is signal processing and applying of AI to this joint communication and sensing, which you'll see it's a big component of 6G. And she's also a IEEE fellow. She has got a lot of awards in IEEE paper publications and so forth. And I think some of them are certainly on the her Joint Communication and Sensing. And she's a founding member of the Signal Processing Society's technical work group that's on integrated sensing and communication. That's 6G has big plans for ISAC, integrated sensing and communication. So, and then we moved to the industry, and all of you know about Nokia and Ericsson, right? So here, Jorge Escobar. He is a 5G security architect at Nokia Federal Solutions. And I think he has been focusing on working with the government on secure and innovative 5G private networks, accelerating them for real use. As you know, that's one of the capabilities I think in 5G that's not fully utilized yet. A lot of power, right? Security and so forth. So that's really awesome work. He also speaks quite a bit on national forums like that on 5G cybersecurity. And last but certainly not the least, Ken Kaminski. He is the director of cybersecurity for regional carriers, utilities, and so forth, and the US government for Ericsson. He actually is a primary point of contact for security and privacy issues for Ericsson's customers. And Ken is also really, he participates in national events like that, speaks quite a bit on cybersecurity issues. So great to have all of them. Please welcome them. Thank you for being here. So what we'll do is, as I said, let's get started with all of you panelists talking a few minutes about what your focus is. Dr. Weiss, why don't you go first?
So thank you for the kind introduction, Arup. It's a real pleasure to be here, and I'm sorry that I couldn't be there in person to meet with you and speak with you. As Arup mentioned, I'm responsible for applied research in the FutureG office, which with specific focus on Open RAN technologies and integrated sensing and communications. The integrated sensing and communications is a new line of effort for us. We've been defining it, and I know I've been working with many of you to try to understand the state of the technology and state of what's possible today. On the Open RAN side, many of you may be aware of the Okudu initiative, where we will be working with DeepSig to develop an open source CUDU that will be managed by the Linux Foundation. It's a major focus for us, and I think it creates many new opportunities, both commercially and for government. So, I mean, security and privacy are obviously major concerns for these efforts. Open RAN, I think, creates a lot of opportunities for economic security in the country, but at the same time creates new attack surfaces, as Arup mentioned, that have to be monitored and protected against. So, we do have some active efforts to try to understand that, at least at present, mostly through a small business grant process that we've been running. The integrated sensing and communications is an interesting area in this regard. I think in some ways it can protect privacy, and in other ways it compromises privacy. So I think there's an interesting balance to be struck, and I think it's important for us to ensure that the kinds of values that we as a nation value are reflected in the practices and standards that come out for FutureG. I mean, that's very much top of mind for us. So with that, I'll pass it on to the next. I don't want to take up too much time, so we can get to questions.
Thank you. Dr. Woodward, please.
Okay, this is on, yes?
They'll know.
Yes, okay, great. Yeah. Hi, my name's Ted Woodward. I'm the technical director for the FutureG office within OUSW R&E. in the Pentagon, and I'm here today because I'm not based in Washington, but I'm based in San Francisco. So make a trip down for the day. And in that role, I support the principal director of the initiative, Dr. Thomas Rondo. Many of you may know him. He gets around. And I support him across all of the lines of effort. So while Dr. Weiss directs 2 of those, we have 5. And I support across all of those different lines of effort. I'm not going to say much about my background. It's just a lot of experience with communication systems, sensors, networks in both the public and the private sector and government and entrepreneurial work. So just thinking about 6G and what's going to happen in 6G, I think the thing to think about there is the new features and capabilities that are being brought to bear from 6G that follows on the general theme that we have within the FutureG office that we can really no longer within DOW go it alone with fully private, exclusively developed communications and networking systems. We need to find a way that we can connect to the high levels of investment flow that are happening in commercial wireless networks. So that's kind of the thesis of the FutureG effort, is how do we do that? How will we accomplish that? And it has a lot of interesting consequences, not the least of which is that now we tie military success to commercial success. So it's important that we have successful commercial technologies with trusted supply chains that can be used for these defense purposes. I should probably also mention before I go much further that should not mistake any of the things that I have to say with the official policies of DoD or the U.S. government. These are my opinions off the cuff based on my experience. So I'll speak a little bit more freely about that. So let's see. There's a lot of interesting things that are coming out in future networks. Martin mentioned a couple. I'll mention a couple more. So integrated sensing and communications, which you heard about a little bit in the morning session, is a very interesting area for us because it offers the potential for added service, added capability. You can think about that within the context of the DoD maybe never met a sensor it didn't like. There's always something interesting to gather information about. And it's not as though we wouldn't know how to deploy sensors that would detect many of the things that you might detect with integrated sensing and communications. But the ability to do it at scale across large areas makes it very expensive. And so you could think about the opportunities that presents for you. Another very interesting area for us is non-terrestrial networking. We'll probably talk a little bit about that. Because that offers sort of the holy grail for communication. We could reach anyone, anywhere, anytime. Again, DoD is not unfamiliar with non-terrestrial networks, but scale, scope, the ability to reach large numbers of endpoints, the disruption that I think 3GPP is likely to bring to the proprietary satellite SATCOM market is worth thinking about carefully. And then I'll just kind of, Martin also mentioned open systems. Open systems are quite interesting for us. We think that's a very promising direction to go in for enhancing many of the features of these systems. I'm not a security expert. I'm happy to be here with all of you today. Because I'm interested to hear your perspectives on what the implications of some of those things are. I'm reminded of a discussion I had with the CFO of my startup some number of years ago that stuck with me, which was what he said to me was, the things you think about every day, I never think about those things. And so I remember that. And what I was thinking about was, when am I going to get my PC boards built? When am I going to get my supply chains taken care of? How am I going to fit the latest algorithm in the FPGAs and maintain the cost of those FPGAs appropriately? And he just never thought about that. So what are the things that I never think about, that you're thinking about, that we can, have productive interchange between us. So I'll close with that and hand it off to my neighbor.
Yeah, go ahead.
Yep. Okay. Yeah, I thought about. I think a good use of this when Arup was talking to me about this was to share with you, because this being a research environment, share with you the areas in 6G that Ericsson sees research where we need it done, and then areas that Ericsson's normal engineering processes and interface with the standards bodies, we generally do these things ourselves. So when you're looking at 6G, some of the major topics, the things we would do ourselves is there's three of them. The whole area of post-quantum computing, the algorithms are coming out of NIST. These are just integrating in. We'll handle that generally. Another area is radio interface security. So upgrading the strength of the symmetric algorithms from 128-bit to 256, that's also, we'll handle that in-house. And then we'll also handle trust model issues, things like if we have SIMs that are connecting to the infrastructure versus some of the newer ones that are out there, like using PKI and TLS, we'll handle those things ourselves. So the areas where really on the research side are things like AI. There's a lot of stuff there. There's a tremendous amount of research going on there. So we're looking to figure out, generally, what do we standardize? How do we do all those integrity, privacy, and provenance controls that are needed within that, and then how to integrate that in the security side. That's a big area of research. Another one is in service exposure, API security. A lot of the technical side of that we'll do, but there are so many more use cases coming in with 6G, and that whole architecture is expanding so much that there's a lot of research opportunity there. The whole area of integrated sensing and communications, the ISAC stuff, we'll chat about that. That's all open to research, figuring that out. And then the last one is in differentiated services. There's a lot of different use cases coming on board where you have to provide different security, performance, trust guarantees across all these different types of users and devices and applications. So that's a huge area also of research. So those are the areas we look to, collaborate with the research community and work together with.
Thank you. Professor Prelcic.
Hello. I wanted to explain a little bit the things I've been doing in the last few years. I think one contribution that was really interesting and exciting for me was contributing to all these working groups that IEEE created, both in the ComSoc Society and the Signal Processing Society, or joint groups, where we try to get the research community excited about integrated sensing and communication. This obviously started like 3-4 years ago, I think even more, 26 already. So yeah, I think that really got to the point of making this technology known to industry, to researchers in general, new students, faculty who were looking for new things to do. And I think we were very successful. We created a lot of special issues in main IEEE journals, in main conferences. And now this year is going to be like the first IEEE conference focused on ISAC. It will be in Portugal, in Lisbon. So in a few years, this area has grown from almost nothing to an area of its own. That's more like a service in my case. I've been also working, of course, myself on this topic since a lot of time ago, since I think my first paper on this topic was around maybe 2018 or 17, I would say, in the area of sensing-aided communication, how to exploit information from sensors to help the communication itself. Like it could be, for example, automotive radar. How can we use that automotive radar? It's already in the vehicles to speed up the bin training process, for example. That was a working line, and then immediately with my background on millimeter wave communication, we started to work on high accuracy joint localization and communication for vehicles. And then we started working on how to exploit full duplex circuits to enable monostatic sensing simultaneously with uplink transmissions and downlink transmissions. I think my group has pioneered with a work that was published just last month, the first system that is able to do everything at the same time. We have been working also on the distributed aspect over the last year. I think this is the missing piece. To me, ISAC has focused so far on understanding the limits and the capabilities, the trade-offs, when we have, let's say, a single pair, a single transmitter-receiver pair, a single link to implement the sensing function. Now, the work on last year has started to focus more on using the network, the whole network, to sense, and the distributed aspect, how to do centralized sensing, distributed with a coherent, non-coherent, with a centralized point that introduces some security issues too. So there are so many different configurations that really have not been studied, not even in research on basic problems, that the area is really now becoming very interesting, in my opinion. All the work we have been doing has been funded in general by industry. We had initial funding from Nokia, from Samsung. Right now we are, for example, working on a project on UAV detection and tracking using uplink signals from users. We were working with Toyota on high accuracy localization, also in LEO satellite communication for vehicular localization, and also a lot of machine learning for wireless in general. What are the interesting problems? One clear bottleneck is the overhead of channel estimation. Channel information is the key to implement many awesome gains in the system, but channel information is always imperfect. There is always that limitation because our overhead is always limited. So how can we use AI to go further and with very few pilots to have a higher quality CSI? That would be great. And I have another student, for example, working on those topics. In general, the integration of AI in the physical layer, I think, is very interesting, but always without forgetting about the models that we know well and in some cases work well. And that's a summary of the work I have been doing in my group here at UCSD. Thank you.
Thank you.
Yeah, so first, thanks, Arup, for the opportunity. I guess from my side, I would like to kind of walk you through how a company like Nokia Federal Solutions is trying to help. So our main mission is to help our DOW partners and, in general, the federal government to kind of use the technologies that we are producing in different segments. So obviously, when we talk about 5G, 6G, we're talking about a technology that is mostly developed for service providers, for your MNOs. So we have the opportunity to bring these technologies and see where we can fit them the best way we can to the mission that our partners in DOW or Department of Energy have as their core mission. So when we talk about things like ISAC, when we talk about 5G, 6G, when we talk about cybersecurity in those technologies, we in Nokia are trying to make sure that we can bring technology that is already there. In a lot of cases, there is some customization that needs to be taken and needs to happen in order to apply to these networks. But the holy grail now, or where we think we can help DOW to be more agile in everything they do, is to try to implement those technologies as they come from the commercial side. And the big advantage for our partner in DOW is that there is a lot of savings, economy of scale that they will take advantage of because these technologies have been developed and paid by, not entirely by other segments, such as service providers. So the other side of the equation that I want to bring the attention that we will talk about is that when we talk about things like ISAC and all these wonderful technologies, we always need to keep in mind that somebody is going to have to make the initial investments, and that our service providers cannot absorb the entire cost starting this technology. So when we talk about ISAC, for example, where we envision all these networks being deployed by the MNOs and having all these radio sniffers around the US to help with the cost, we also need to think about what is in there for them, right? So in my experience, I worked for the service provider space for many, many years. And that's a question that we always have to keep on mind when we talk about these technologies. But the good thing in this 5G world and the 6G that is coming is that I think more than ever, and this is going back to the statement of Dr. Woodward, this is my opinion. This is the best time that I've seen on this partnership working so far. So I think we're in a great point where we can help the US government fairly quickly compared to what they are used to. And the other part of my work that is very exciting for me is that also for the first time, or we are in a time where cybersecurity is not considered after the fact, right? We are able now to design networks from the startup, having security as a starting point. So when you compare for the old guys like me, I was implementing first generation wireless networks back in the 90s in Latin America, moved to 2G, 3G, 4G. It is amazing now from 3G, 4G, 5G, when IP is obviously core to every network, the level of cybersecurity considerations, not only from the companies, not only from the operators, but also from the standard entity. So even though in 3GPP, radio is still the king and core is still the king as it should be, cybersecurity is being now part of the conversation from the startup. So that gives us also a level of confidence that we can help critical networks like the ones that DOW is working on. We can have some cybersecurity considerations right on the top. And also the other part on that cybersecurity is when we talk about tactical networks, and Arup mentioned a little bit about 5G and private networks. We are working very closely with DOW on networks that are being deployed in the warfare theater, right? So these are critical. It doesn't get any more critical than having a 5G network or 4G network operating in a war zone and lives depending on it, right? So with these cybersecurity considerations, the way we operate these networks, I feel very, very lucky to be at this point because it has been a long journey. So hopefully we can share some of those experiences.
Thank you, thank you. So just a brief note on ISAC, people who haven't heard about it, because we'll talk quite a bit about it because it's so important, not for commercial, but the actual defense, national defense. Integrated sensing and communications is the capability that will add radar-like sensing capability to the base station itself. Right now, a base station knows all the devices that it's connecting to. Now, with sensing added, it will also know whatever it wants to know about the surroundings without them being connected like a radar. So that's what the ISAC. And there is, of course, that's the simple statement. How it is done is a big open area now, right? So I'll start with Dr. Ted Woodward with the business case. What are the use cases do you think? Military and commercial, we want likely to have them both, driving the same thing. What are the use cases that you think will really be important for ISAC?
Okay, thank you. So I'll say a little bit about that, and then I'll probably hand it off to Martin to say a little more about that because he leads the ISAC line of effort within our FutureG team. But I think to start off with that is to say that there's two kind of things you're interested in. One of them is saving money, and the other is doing things you couldn't have done otherwise. So ask yourself, what are the things that are going to allow me to do things that I would otherwise have to have an exquisite, very expensive sensor, or that I could do in ways that I couldn't do before. So the two things that come to mind there are doing things at a greater scale and doing things at greater scope. So you can imagine a nationwide network that's capable of delivering insights that you wouldn't easily be able to get, because it would require you to deploy a vast network of very costly sensors. So these are I think interesting things to think about. Martin likes to talk about two different varieties of sensing. There's the infrastructure-based sensing, so you can imagine vendors like Nokia and Ericsson incorporating features within their infrastructure. So there's stuff sitting in the G node B that allows you to do things that you weren't able to do. So you think about radar, that sort of thing. So that's one dimension. And then another dimension is something that sits outside the network. So just receivers. I deploy receivers, they see the signals that are coming off of these base stations, and they can process the return signals coming from different things and develop insights from them. And it doesn't take much to see that that doesn't require you to mess with the infrastructure necessarily. Although if you did mess with the infrastructure, maybe you could do things that you couldn't have easily done. You should get a little bit of help from the network, for example. So I think those are important. That's an important taxonomy distinction here. And then another one is public versus private. So you're going to do this in a public network, or you're going to do this in a private network. So that's all different areas. So in terms of the killer application, the observation that I would make, and I think this comes from some of the workshop studies that Martin sponsored, is that the industry is not clear on what that killer use case is. We don't exactly know. And furthermore, the insight I would take is that we don't even have the mechanism to find out. Because in order to find out, you probably need an at-scale playground to experiment with some of these things. And that's not easy, to put in place. So that kind of dodges the question of sort of what will be the killer application. But if you look at the 3GPP lists, I mean, they had a document with 60 use cases listed down there. A very comprehensive assessment of different things that you could do, ranging from healthcare to environmental sensing to object tracking to location-based services. There's a large number of things. And I'd be very interested to see if there's any consensus within the group here as to where those are likely to be.
Yes.
So, so it's then it gets to be speculative.
Okay. Well, I mean, I'll draw Dr. Martin in then.
Yeah, maybe.
But let me clarify. And Martin, you can consider that too while answering. What about drone detection, right? I mean, that's a big national problem. Is that one, Martin, you think or don't think? Or eventually, I have to be frank, I don't see that I need IJAK as a person, right? I mean, all of you, I don't know that you'll have need when you're talking using your personal phone in non-clear communication, you need IJAK, right? I mean, so with that in mind, do you think, Dr. Weiss, that actually the national defense use case, like drone detection, can actually drive implementation of IJAK as the first, primary force? What do you think?
I think that it's an interesting use case. I'm not convinced that drone detection by itself is going to be something to build a business around. But then, I'm not the one who's got capital at risk the way, I really appreciated what Jorge was saying about the interplay between the carriers and the manufacturers. I mean, this is a really complex dynamic that's evolved over a lot of years where, there's a lot of different capital at risk to come up with these types of applications. So in my position, I don't perceive those risks. I can't make those kinds of trade-offs. And so I concur with Ted that we really need to discover, what it is, or we need to allow the community to discover what the killer applications are, or what the useful applications. I don't even like the term killer applications, right? But the useful applications for this are. given that this is, hosted by the Internet Society, I mean, many of the things that made the Internet so successful was that it was possible to discover applications, information service types of applications, by people who, perhaps weren't involved in the design of it itself. So, I'm old enough and I've been around the industry long enough that I remember in the 1990s, there was this whole, actually 80s and 90s, this whole intelligent network types of effort that was being carried forth by the communications carriers, the local telephone companies at the time. And they were thinking of all kinds of interesting things that you could do with information systems. And they were, well, let's say nobody's using them today. I won't say that they were wrong, but the way in which things were developed, the way in which things evolved, the things that were developed were things that just simply couldn't be envisioned at the time. And I think that we really need to leave the door open for this kind of discovery. And so I guess I would end it there, but happy to discuss that further with other folks.
Yeah, no, thank you. Let me check with our industry folks. Jorge, what do you think? And I will come to Ken.
So, yeah, no, that's a good point. So I totally agree with Dr. Weiss as far as I never think on when I look at ISAC, we never think of like killer application. So two things that we in Nokia Federal Solutions think about ISAC that are important here is one, that we need to start playing around with this technology. We cannot wait. So one thing that we cannot wait, and this is not just my opinion, I agree, but it's the company line, is we cannot wait for 3GPP to decide everything for us, right? 3GPP is a great standard body. They are very good at what they do, but it takes time, like any body of that magnitude. And I think where we are today, we can start to demonstrate some of the ISAC capabilities. We have done, and I know Ericsson has done it as well. We have done some field testing where we have, introduced some sort of architecture that is in their early years, if you will. But we have demonstrated that we can censor these devices, drones, some environmental things like rain and other things with this network. So it is doable. We need to partner very closely with DOW so we can play around with this technology. I think the partnership between industry and government and universities is critical to make this thing move faster. But the line is we are ready to go out there, show what we can do, get the government to tell us what else they need, and move faster than we usually do. So that's, I think, one of the key engagements or key technologies that we see in Nokia as a leapfrog for the US government to move ahead of the competition, if you will.
Yeah, good thinking. Ken, do you want to?
Yeah, agreed.
Ken,
yeah.
when you are done addressing and start talking about what you see as the security and privacy issues that ISAC brings.
So Ericsson is doing the same. So we've already, demonstrated this, and we're looking to work quite closely with the government and with DOW. We're excited because we believe that this is a good revenue stream potentially also for our customers. So monetization is a big deal, and this could potentially be another service that could be monetized by the large carriers, where they could make, a good amount of money, and then you get the capital, you get the investment, et cetera, et cetera. We were looking at the drone detection as probably being the first, particular use case. There's another one that's kind of interesting as you're looking around critical infrastructure or border security too. That's another one we've been talking about. So you have, around a border, around the perimeter of maybe a port or a dam or some piece of critical infrastructure. This is an interesting area too if you had the sensing integrated in with the comms, because now you can look out to see what's going on potentially in the airspace and even on the perimeter there. And we look at this as maybe even potentially being a use for the mid and the high band, because the higher you go up in frequency, the better you get in terms of detection. But then your distance and you get clutter issues and things like that. But this might be an area where even millimeter wave around the perimeters, that's something that's not generally deployed there. You see those in dense urban environments, stadiums and something, but that could be a potential if you had the integrated capabilities to have that integrated around there. So that's another possibility there.
Professor Prelcic now. I mean, you did mention that we haven't really looked at the power of using the network, right? And you are doing a lot of advanced research in general on intelligence, sensing, and communication. So talk about what are the possible, because nobody knows the architecture, what it's going to do now. There's not a single architecture, right? There are different options, different capabilities. What are your thoughts on the possibility of different architectures that can be available for
Can I say something about the previous one first?
Yes.
So I just wanted to mention quickly. To me, there are two advantages with ISAC regarding it, and this is going to tell us where are the killing applications. To me, ISAC is interesting because it's able to provide a really big coverage. Yeah. Right? I mean, the cellular infrastructure is big, so that's one feature. Another feature is no line of sight localization. Standalone sensors are limited to line of sight, right? So no line of sight localizations, applications that require these, which are many, are also going to benefit. It's difficult to say. This is going to be the killer application, as all my peers are discussing, right? But applications in transportation where no line of sight limitations of current sensors are a problem. Collaborative perception in vehicles in general. And then applications that can benefit from this huge coverage are low altitude economy. To me, this really is very important. Okay. Flying taxis, any kind of flying object at low altitude, delivery drones. Who is gonna manage all that?
There you go.
So we are going towards a society which is going to be completely automated, like humanoids, automated vehicles, ground vehicles, automated aircrafts. So to me, the communication network is going to be the brain of all this, because it's impossible to build an alternative network of sensors, right? And this goes to the next question, which is, what is the best architecture, in my opinion? Yeah. This is only my opinion. I have to say I'm not a big fan of these ideas proposed lately, where people are proposing the introduction of new hardware, like these sniffers that we are going to put here and there. Right. Well, first, to introduce these outdoors, you're going to get into the battle of the permit to locate it on this facade, on this interesting traffic light. So we do not own the public space. Getting permits to deploy things in public space is a huge problem. Second, we have a huge network with many types of devices and many base stations which are already covering the area. Maybe we can refine the deployment so we can introduce sensing coverage aspects, and even sensing coverage aspects that are tighter or not that tight. For example, for perimeter protection, we can have we can study the deployment of the network, so we have a very high probability of detection very close to the perimeter that is interesting for us, and we can allow lower detection probability when we are farther. And there are so many things we could do with the network itself that I don't
without
see
bringing in any other equipment.
Exactly. I don't see the need of any other equipment. And the thing is that some people don't really understand very well how the cellular network works. The cellular network provides by itself some level of synchronization in many of the operations. For example, there is the protocol to estimate the uplink channels in the multi-user setting. So in that situation, the base station is first synchronizing in time all the users that are going to transmit the signal for uplink channel estimation. So those users are already pre-synchronized. Those channel estimates are already pre-synchronized in time. Yes. And the information about targets scatters in the environment is embedded into the channels. Right. So the uplink has not been studied at all. The uplinks, synchronized uplinks that the cellular network provides for distributed ISAC, this has not been studied. And it's super strong. Of course, there are other challenges if we use user, which is we also have to track the position of the user itself. Yes. And then we can also do distributed with only base stations. Right. We know the position very well and we can pre-calibrate. So there are so many other options that do not require alternative hardware that I'm not very inclined to bet for that. Okay.
Yeah, so I think somebody already mentioned, right? I mean, let's look at the security concern here. Wonderful capability, but then all that information is available to the base stations, right? If they do sense. So just want to see whether Dr. Weiss, Martin first, and then Ted. What are your thoughts about it?
So, Nuria, I very much appreciate your comments, and I think as an end state type of a situation, that it's largely true in mass surveillance that there's plenty. We don't really need extra hardware, but the reality is that in order to get new features, services, so forth, and approved within the carriers, it's a years-long process. Just because they don't want their bread and butter services disrupted. So I think there is a role, certainly as a transition, for these independent sensors if you need it today. And for us in the Department of War, there are some immediate needs, especially as we start thinking about the drone detection problem. I don't want to lean too much on that, but there is an immediacy about that can't really wait until carrier-based solutions get rolled out into the network. The other place where we could see passive sensing, 5G passive sensing, is in situations where you can't expect cooperation from the infrastructure. Now, in domestic situations, that's not really an issue because the carriers are generally considered favorable to where we are. But if we imagine places where the military might deploy, they may not be able to expect cooperation from the carriers, and so they may not be able to take advantage of the integrated sensing and communications. The last thing, circling back to security, I know, Arup, you've been trying to get us to talk about security, and so I will do that.
Thank you.
Especially, and again, I'm thinking about this from particular military types of situations. There's a data stream that would come out of the carrier systems that would have tactical interest. Especially you think about applications like drone detection around critical infrastructure. We may want to be able to protect that information. And so how is that going to work, practically speaking, so that the operational security and so forth of that information is protected? If you deploy separate sensors, you have control over the entire thing, and you're able to provide that degree of security. So I think there's several dimensions to this, and the issues that you brought up around the difficulties and costs of getting permits, of siting equipment, et cetera. Those are totally valid, and they kind of fit into the broader economic framework for deciding what kind of sensor gets deployed in which type of application.
Thank
Okay.
you. Yeah, please.
Yeah, okay, so I think there's a lot of interesting stuff to unpack there, and so start off with where do you think this is going to get rolled out first? The public network, the private network,
Yeah.
or in some other way? So the interesting things that have come up in some of our discussions and thinking about this. So imagine in a public network, right? In a public network, you have the advantage of a diversity of use cases. So a public operator could potentially, see a monetization stream from multiple different things, location-based services, environmental services, biometric monitoring, other things could all generate revenue and could justify me putting this in place. On the other hand, a private network that was focused could deliver on a specific use case that they wanted. So imagine a private network for a mining company. They have a distributed communication network that they need, and putting in a private 6G network might be attractive for them. But if you could add to it, say, vehicle and hazard tracking at the same time, so, okay, now I can monetize that, so I can afford to put that in place, and I can sidestep all of the liability issues that come up for a public network operator. So imagine a public network operator that wanted to do all the things that I just talked about wanting to do, and they failed. Okay, I contracted with you for that service and you didn't deliver it for me. And there might be a hazard associated with that, and I might sue you. And that's a real, consideration for many folks. And you could imagine that you would see that happen differently. And then in all of these cases, we just talked about the need to put it in the infrastructure. So if there was a passive deployment of an actor who's just putting the receivers in place and delivering the service, they don't have to interact with the network operator if they don't want to. They can deliver, whatever capability they think they can deliver, and they can do it independently. You might bet on that happening first because it took the least amount of time. But in all of these cases, there's the issue of data privacy and integrity. And it's a huge issue, right? The different dimensions of privacy and integrity in the network, out of the network, beside the network, protecting your data from being extracted by third parties. I think there's a lot of challenges there, and what those capabilities represent, right? Yeah. We know, all of us know, that the operator derives a great deal of value from location-based services, but increasingly, what is happening? Well, we turn those services off. Like, no, I don't want you to know where I am or what I'm doing. And in the instance of an ISAC-based capability, you don't have the ability to turn that off. So I could recognize that it was not just a person or people walking down the hallway, but it was a root walking down the hallway, because I could determine that. And if I can determine that, then I can determine a lot of things that you might not want to be determined. So what are the policy implications of all of those? I don't think we've worked them out. Are we going to start carrying around ISAC defeat mechanisms with us? Cell phone jammers, so that we don't want people to know where we are or what we're doing. This is, I think, this is something that needs to get worked through. This question of authorized or unauthorized information extraction and exploitation. Yes. And these are important questions for us as a society, I think.
Absolutely.
I think this is a very strong point, and it's exactly one of the reasons why the architecture that relies on these passive sensors is not my preferred. I think right now this can work because the operators are not protecting data like the CSI, right? I mean, they are not protecting the signals that are being used to extract the CSI. There is no one is thinking, okay, someone else there is going to be trying to read my signals to extract the CSI and read the scatter. So that was never protected. Now that those signals are useful for sensing, people have realized of that, this is going to change. And I think the operators and 3GPP will define different ways to protect those data, exactly because otherwise that can create legal issues too, right? So relying on signals that are extracting information now from parts of the signaling in 5G that are not protected may fail in the future if those fields of the communication frame become protected and become only, let's say, readable to the users of the network or to other base stations. So I think it's very easy for the network itself to allow that usage to its own elements, and it's easy to protect it from others. So that's why I always thought of that solution as, yeah, it is working right now, but given all the concerns on privacy and security, I'm sure this is gonna change. So that's, to me, one of the concerns there.
Yeah, when I think about this, I kind of divide the security problem up into different kind of buckets, because you're going to have a network that this is going to be on, so the trustworthy, all the security mechanisms that we've built into the network still come into play. Then there's all these applications we're adding on the back end, because that processing all has to be done somewhere. Some processing gets done on some of the network gear, but then there is servers in the background doing all that processing to come up with the velocity, the location, of all the different targets that are out there. So you have all the security related to that piece. And then, as Dr. Woodward was saying, you have all this new security related to the sensing. And that's all the privacy, how do you protect all that data and stuff like that. So I think it's kind of useful to divide it up into those areas there. And then we've even had some internal discussions, like on that consent framework that you were mentioning. What does that even look like? If there's someone there that's connected to the network, well, you could use the consent mechanisms we've already built in to the network for that. But if they're not, then they're not. So sense them anyway. If it's public safety related, we're going to sense that anyway, in those types of applications there. So, yeah, what does that really look like, that consent framework, in terms of that?
Yeah, so let me kind of give you also some multi-domain, multi-dimension issues with any new technology, right? So as we had mentioned, this is a multi-dimensional issue. You have a network, right? We have secure networks. You can argue good or bad, but we have secure networks for many, many years. I think first thing is, at the network product level, you have to do the best job that you can making it secure. So from supply chain to everything that is product-wise, you have to keep that into consideration. The network part, obviously, as any 5G network now, talking about 6G, where ISAC is going to be standard on 6G, those network considerations, and now we are adding things like AI, there are new things that are going to come out that need also to be looked at from a cybersecurity standpoint. And then we get into the other dimension, which is operation of the network, right? So if it's private, okay, things can be easy. But if it's public, it's a whole different animal. And operational-wise, you have to have the right processes and the right personnel, trained and capable of operating a network in a safe manner. That goes from incident response to configuration to everything. And the last part, which I think my colleagues here have brought up, is the policy part. So policy is a different dimension of the same problem. How you make sure that this information stays where it needs to stay? What can be shared, what cannot be shared? If it's out of a public network, what safeguards you have there? Just to use an example, when you're talking about healthcare or the group in Europe, GRPD for data, those are highly tight programs that make sure that privacy is number one. That's policy. That's a group of people, governments saying, this is how we are going to do things, and everybody has to follow. That's a highest standard to follow in the network, in the service provider, and that's another challenge that needs to be taken into account. We can have certain policy here, but think about, just to go extra, roaming. Are you going to allow roaming for these services? How about if you're doing international roaming? What kind of information you're going to allow to have in other networks that are the not trust network? So again, product network, operation of the network, and policy, all of those things need to be dealt with before we have a comprehensive set of rules to operate an ISAC in the public network.
Cool. I think we are, I'll make sure we stop at a reasonable time, but this may be a good point before we bring in a new issue here. I think with AI, I think we'll go to AI, but I want to see if any of you have any questions.
So the very easy question. So when you look at the base stations, their antenna is looking down.
Downwards.
If you want to do communication and sensing together, and especially like detecting drones, you have to tilt up. Then I don't know what we mean by communication and sensing together, especially if the antennas are looking down. Because, I mean, she mentioned that in the downtown area, because of all the side ropes, it's actually very, very difficult to detect. So, I mean, yes, in the sky, it's actually easier to sense, but then there's no one to communicate with when you look at the antennas looking at the skies. And the second question is, I mean, there are many ways to send RF signals. And when we send RF signals overriding some of the sensing signals, then it will be very, very easy to actually confuse the sensing. Then how can we trust the sensing values? And so I think a lot of 6G people are talking about sensing and communication together. I think it's maybe too expensive. I mean, from the practical security guy perspective, what do you think?
Okay, well, I'll start out. And the answer will be AI will solve all those problems for you. And it's a bit of a joke, right? But not completely, because, of course, AI and these are techniques for extracting correlation and sense making in ways that we've never anticipated before. But I think all the points that you're bringing up are very important and relevant technical questions about how are we going to do this. And I will observe, right, that the ability to do integrated sensing and communications is not a new thing. Going back to the 90s, people have talked about the ability to detect people through walls with Wi-Fi signals. I read the papers. I didn't write any of the papers, but I have seen them. But what's different about it now is the industry is talking about doing it. They're talking about doing it at scale. And that's what I think causes us all to sit up and pay attention. And there can be many potential roadblocks along the way, like you mentioned. And then there's counter arguments, like you also would have mentioned had you had more time. Like there are actual cellular networks that do look up, and you might collaborate between those things. And if there was a need, or if there was a need and value to be had from adjusting the antenna coverage, hey, I'm sure our colleagues from Nokia and Ericsson would be only too happy to show you inventive ways of doing those things.
Yeah, true.
Yeah, he's got some.
Yeah, and there are, like in the mid-band, like with N77, there are some restrictions right now, depending on that. So there's, issues with some existing satellite communications where there are up-tilt limits on that. And we've run into this with some of the work that we've done. So you might find that there. There's also power flux density limits with some of those, but that tends to be in the N77 on the mid-band there. And I think there was the altimeter stuff that all was a big kerfuffle too, just a couple of years ago with that. So yeah, you'd have to work those out. But if the use cases are there, I think, all parties would be happy to do that. We'll be happy. There's money to be made. We're going to.
Yeah. Anybody else wants to join? Yeah, I would say that I think I was thinking about what Professor Prelcic was saying. I mean, adding a separate set of antennas just to transmit like pilot signals, right, for CSI. I mean, that's a frustrating, and Canon Jorge will say they are easy to add that for the providers. So, any other requests? Anything else? Okay, cool. So if no other questions, we got. Let's go into the AI because I think that's really. I'll start with Professor Prelcic because her research is focused on that. So do you want to start there, and we'll go to others?
Any specific question or in general?
I think right now, I mean, I was thinking about particularly, what are the major roles it's really have to play that there should be, we should design for, right, or think about in 6G particularly. Is it, I think Jorge pointed out, I think monitoring is always really, and that, I think based on what I played with agentic AI, I think that what it can do blows my mind. So I think some sort of those networking monitoring with agentic solutions, not just AI/ML, I think to my mind comes. What are your thoughts?
Yeah, I mean, obviously there is the part of managing the network itself, which is very appealing topic for using AI. But I think this has to go to all the layers. Even the physical layer can benefit and maybe solve or mitigation of the problems that have been a bottleneck for years and years, like multi-user MIMO is not really working at the level it could work, distributed MIMO. And mainly the issues are related to understanding the channel well, right?
Yeah.
We can do many things if we know the channels. So estimating the channels, predicting the channels is really important. We need it for beamforming, for creating the beam patterns that cancel the multi-user interference, that take into account the interference from another neighboring cell. So all these radiations that we, let's say, ad hoc create in every base station, in every user, they are based on the channel information. But the channel information that we have in general in current practical systems is very limited. First, because during the estimation process, we don't want to spend too much time sending pilots to estimate the channel. And second, because later in some type of systems, we have to feedback that channel information to the base station, for example, about the downlink. If the system is TDD, then you can exploit reciprocity, but if it's not, you need to estimate both the uplink and the downlink. And the cost in terms of I not using the network to send information, but pilots and feedback the data about the channel is just so high that we limit the accuracy of the channel information. And that, at the end, limits the data rate that we can achieve, how many users we can serve simultaneously, really a lot. So solving these problems with AI is interesting. And in that case, we can have many solutions that are site-specific. We don't need to have a network that can, a neural network in this case, or a deep network, that can predict the channel for every possible site perfectly, right? Because the base stations are going to be collecting channel data all the time. So we can really develop site-specific solutions without the need of even large language models, right? That's another topic that is interesting, like large models to represent channels, a larger scale that can be particularized quickly with small retraining at different sites. That's also very interesting. So in general, I see that physical informed neural networks are very interesting to solve all the problems at the physical layer because they are a way to exploit data and at the same time exploit all that we know and all we have learned for many years, and we can write as mathematical models that represents the physics of the propagation environment. So a lot of work to do, not only black box, minimize the power consumption of the network, I have all this data, right? No, a lot of hard work with physical principles and hard machine learning, statistical machine learning. I see a lot of work there.
Awesome, yeah, please.
So I think I will kind of summarize all that Dr. Gonzalez mentioned in what I call a spectral efficiency, most of it.
Yeah.
AI obviously has a huge role in that, and a lot of work in R&D is being done on how to model these channels, how to USI to make it smarter and more efficient. I think there are other layers where AI is going to be a prime facilitator for 6G. So as Dr. Gonzalez was mentioned, it's a multi-layer issue. So the other part will be energy efficiency. So remember, these networks are going to be huge in the amount of compute power that they're going to need, right? So when we're talking about 6G, we're going to talk about most likely GPUs come into play. CPUs obviously will be there by the billions. So there will be a lot of energy savings that AI will help to facilitate. That's part of where Nokia is putting a lot of dollars of investment, trying to make these networks greener, if you will. So it's going to be a challenge, but AI with the right models will be a tool to be used to facilitate those efficiencies. The other part will be the operational efficiency, right? So how the network service providers will be able to operate these networks in a better way. So things like have been used in 4G, 5G called SON, self-optimization networks. With the tools that AI will give us, we will be able to do a better job of detecting failures in the network, kind of predicting when something is going to happen, and go to the next level of fixing these issues before they happen. That will be a huge amount of dollars saving, not only for the operator, but also for the consumer if we do this the right way.
Yes.
And the last one will be the customer value. So customer operations for service providers is where some people don't see it, but it's one of the biggest costs that they have as an operator. So when you think of why these people are contracting services to Costa Rica or India or somewhere else, obviously it's an economic issue. Having these chatbots and other capabilities that AI brings will help also to make the customer interaction more efficient, which in charge is also less expensive for the operators, and hopefully those savings are being passed to the user. So we think AI has a tremendous prospect. The good thing is all the standard, when you look at the radio, like issues that Dr. Gonzalez brought about channel modeling, using the laws of physics to make this as efficient as possible. This work is being done now. 3GPP is taking those things very seriously, and it will be up to companies like Ericsson, Nokia, Samsung, and others to execute on those and hopefully have a more comprehensive and powerful network, but also savings across the entire chain.
And don't forget Qualcomm on the user side, the device side particularly, right?
Exactly.
Yeah, go ahead, Ken.
Yeah, and just a point there too. A lot of those use cases exist today in 5G. So from both, Ericsson and Nokia, this stuff is actually real right now to a degree. So it's not like we're waiting for 6G for this. This is already rolling out into the network now on the AI side. And then also, like with AI, I like to kind of conceptualize it into buckets. So I like to put it into AI, for the telecom applications like we were chatting about. Mm-hmm. And then there's AI that helps defend the actual network. That's an area of ongoing research there. And then you have AI to attack the network. Yeah. And just to comment on that, we hit a watershed moment in the cyber world back in September, about 5 months ago. If you remember the Anthropic attack, where a nation state compromised the Claude Code area of the Anthropic AI ML model there. And this was pretty amazing. They used it to basically launch attacks on at least 30 government, technology, and other types of companies that were quite sophisticated. So, and it went through all the different parts of the attack model, from reconnaissance, exploiting vulnerabilities, to lateral movement. There were humans involved in the process, so they were kind of shooting chunks of this stuff out. But about 80 to 90% of that got processed by the actual AI. And they were able to do things that we've understood. Humans have been doing these things, you know, for years, but this thing rocked out at a rate, you know, that only AI can do. And, you know, NIST looked at that and said, you know, hey, look, an AI agent is the new insider. Yeah. It's the new insider. And that kicked off a huge amount of activity within the U.S. government to deal with this new world, you know, that we're entering here. So we're already here. You know, the future's already here in terms of that. And that was a real moment there, just in terms of in terms of cybersecurity.
All right. Let me check with anyone have questions from the audience?
So, Arup, another aspect
Yes,
of
please.
AI, is, you know, what am I looking at? Identifying the thing that you have, that you think you're seeing on the Isaac thing. I mean, this is this is somewhat separate from the physics part of it. It's signature analysis. It's then tracking things across base stations. I, you know, very much appreciate what Professor Gonzalez was saying about the problem of needing to scale this from, you know, single solutions to a network solution. And this requires addressing not just the physics part of it, as important as that is, but also the, you know, what we think of as the data part of it. You know, what do you do with this data? How do you interpret this data? How do you turn the outputs of the sensing into actionable intelligence?
Very important point. Thank you for bringing that up. So let's see. Yes, Professor Messi.
Thanks. So yeah, really interesting discussion. Thanks, guys. Okay, what about? So one thing that we're concerned about is how do you unlearn or reset? Suppose that either maliciously or unintentionally you've got bad training data in, bad data that's evolved as a system. Have you thought about sort of how you back that out? Suppose you've built your 5G to adapt based on conditions. It's learned, it's trained, and we discover something went wrong with those conditions, either because an adversary intentionally put bad conditions in, or we just got something wrong. That unlearning worries us a lot.
Who wants to take that? Data poisoning.
All right, Dan. We're going to remember your very inspiring talk of the morning. You know, when the infrastructure is your adversary, right? So I can see this is coming up again now. But what I would say there, what I'm thinking about is I'm trying to think about this as distinct from the generic AI problem, right? There's this generic AI problem associated with training data and poisoning of the training data, and how do you keep the training data genuine? And I think we have, you know, the network has that problem, certainly has that problem too. But are there areas in which it is distinct and special because of that? And I don't have a good answer for you that says, yes, for sure, this would be, you know, this would be unique. Other than the fact that you do have continuous observability of the network. So because you have continuous observability of the network, the more of it you have, as you point out, right, the better it will be. And that should, you know, help you pull track the model, have the model track. That's all I can think of.
Let me just offer the following. And again, it's not a solution that I have or anything like that. But I think, like with any set of data, in any way you consume it, right? So now we're talking about machine learning, different language models that are consuming information. This problem is happening today, right? So I will say, as a telecom company, we'll have to learn how to deal with those issues that are specific to this model. So I remember from the old days doing RF optimization with the sun, those issues were there as well, right? You get information from certain base stations, and for whatever reason, that information is not accurate. And then you have to go and look at the algorithm again, go and look at the KPIs, see everything, and fix it manually at that time. That's how we used to do it, at least. And then use that automation in the sun background to keep trying to do the best job that we could with the information that we have. So I will say from the AI, pure AI standpoint, we'll have to build mechanisms, and I'm not an AI expert by any means, but there has to be mechanisms where you can look at the data that you are consuming to create those models and be very thoughtful on how you are checking the integrity of that information.
I think, Dan, some of the answer starts with explainability, and emphasis on explainability of the AI. I mean, if you can explain what the AI is doing, then you'll be able to back out of it. And then I will, tell you that, the answer, of course, is named data networking, but that's a whole nother conversation.
When I was flying in, I was reading through, you got to do something on a plane, right? So I was reading through the NIST adversarial machine learning document. Now that's old, but I remember that they called that out. The unlearning problem is specifically called out as an open area. And that document had the state of research, I think, back in 2024. But in that document, it said, hey, this is an unsolved problem at this point. I don't know where it is, but I remember that with your question when you asked it. Something in there.
All right, I think we are coming to an end. Looking at the time here, I want to not derail their schedule. So let's give our panelists a warm applause, round of applause. Thank you so much.